Okay. So here you can see digital camera. Basically, it is another kind of input device. So it says digital camera have essentially replaced the more traditional camera, okay, the old one that use film to capture the image, okay. The film required developing and then printing before the photographer could see the result of their work. It was the old version of camera. So this made these camera expensive to operate. So it wasn't possible to delete unwanted photographs. But right now, so modern digital camera simply linked to a computer via USB port, and from here, so it says modern digital camera simply linked to a computer via USB port or by using Bluetooth, which enable wireless transfer of photographic payload. So these are steps given. These camera are controlled by an embedded system. So embedded system means combination of hardware and software. Combination of hardware and software at one place. This is called embedded system. So at a time, which can automatically carry out the following tasks. Okay, adjust the shutter speed. These are the steps given for the digital camera. Focus the image automatically. So this instruction basically just get the instruction from the software. Operate the flash gun automatically. In embedded system, there must be a controller. Okay, controller means you can say microprocessor. Right? All embedded system will have microcontroller. Okay, which has own memory unit. CPU. It will have CU, ALU, and memory unit. Okay, so adjust the aperture size. Adjust the size of the image. These are tasks. Okay, so remove red eye when the flash gun has been used, and so on. So these different tasks can be handled by microcontroller, which is available in digital camera. Is it clear? Yes, ma'am. Is it clear? Okay. So here some working is given regarding digital camera. Now it says what happened when a photograph is taken. The first step, the image is captured when light passes. Okay. When you click on aperture or button through the lens onto a light sensitive cells. So this cell is made up of millions of tiny or teeny sensors which are acting as a photodiodes, and these are called basically charge coupled device. We call it charge coupled device. So which converts the light into electricity. Okay, because camera work with the light, so it takes image through a light and it converts into electricity. So the purpose of CCD basically is to convert image into electrical form. So each of sensor are often referred to as pixel. Okay, picture element. Pixel means it is the smallest pixel. Basically, it's the smallest element of picture. Smallest element of picture. Okay. You can say another way, teeny point of light. Teeny point of light. Pixel. Kind of. You can say this dot is a pixel. Okay. Combination of pixel makes a picture. Okay. Horizontally and vertically. Okay. So combination of pixel makes a resolution, which is basically image, and this image becomes sharp as pixels are closer to each other. And these pixels are supported by a number of bits. The image is converted into tiny electronic charge, which are then passed through an analog to digital converter. Okay, picture basically in the analog form that is converted into digital form to form a digital image array. The ADC convert the electrical charges from each pixel into level of brightness. Now in a digital format means 0 and 1. For example, an 8-bit ADC gives 2 power 8 256 possible brightness. So levels per pixel. For example, brightness level, this one like 2 power 8 means 256 combination. Okay, got the idea? Yes, Naima. Move to next page. Photodiode, basically, it is given in this here. It says this cell is made up of million of tiny sensor which send the data, which are acting as a photodiode. Which basically, here example is given CCD. Purpose of CCD. Photodiode are basically CCD, which convert light into electricity. Because camera capture the light, okay, work with the light. So it need to be converted into electricity, because when you attach a digital camera with the computer, so that must be converted to electricity, and that electricity is converted into binary form. Electricity means 0 and 1. You can say 0 and 1. It says photo. Photo means it is a device which takes photo of the object. So here is description again. Photodiode, charge coupled device which convert light into electricity. And each of the sensors are often referred to as a pixel. Basically, it establishes a pixel. Pixel is a basically picture element, or you can say teeny point of light, since they are teeny components that make up the image. And with the combination of pixel, or with the help of pixel, you can make image like this one. Okay, so these are closer with each, so the image becomes sharp. It depends on how closer pixel with each other. So the ADC, then say the image is converted into teeny electrical charge, which are then passed through an analog to digital. And then these pixels are passed through ADC to form a digital image array. Means these pixels are converted into digital form like this one, 0, 111, 0011. Got the idea? Okay, moving to next page. Here you can see further working in given in picture. Now it says apart from brightness, the sensor also measure color, okay, which produces another binary pattern. So most camera use a 24-bit RGB system. So each pixel has 8-bit representation. Each of the 3 primary color, okay, a red, green, blue, okay, red, green, RGB color. It is standard. It means 2 power 8 means 256 color. So red, 256 for red, 256 for green, 256 for blue. So you can imagine, you can image how many pixel can be produced by multiply by these each other. And producing pixel basically create an image. So it says, which means each pixel has a red value 0 to 255 in binary, a green value 0 to 55, and a blue value 0 to 55. For example, a shade of orange B215 red, 165 green, and 40 blue, giving a binary pattern of this one. Or D, in hexadecimal D7A528, written in hexa. Okay, here is given a charge coupling device, matrix array of sensor. These are all sensor which basically capture the image. The orange pixel has brightness value of 115. It says 73 in hex, or 0 111 0 0011 in binary. So you can see that how basically color is produced. Now remember, pixel needs a bit. As we assign more bits to pixel, more color can be produced. Like if we assign 1 bit to a pixel, like 2 power 1, so it can produce 2 color. If we assign 2 bits to a pixel, it can produce 4 color. As we increasing number of bits to a pixel, it increase number of color. 2 power 3 means 8 color. 2 power 4 means 16 color. Okay, so on. 2 power 8 means 256 color. Same like if I give 2 power 16, it can produce 65,000 color. If I give 2 power 24 bits to a pixel, it can produce 16.3 millions color. Okay, so now you can imagine that how many color we can produce. Now right now we are producing billions of color because now we have 32-bit monitor, 2 power 32, you can image, or 2 power 64, and 2 power 128 bits. So these kind of monitor has come in the world. So they are producing billions of colors by using such technology. Now here you can see further working, like image is captured by lens convert into single form, and here a CCD, charge coupled device, an array of pixels which send these data to ADC. ADC can, this basically CCD takes data in the form of light, okay, and it is converted into electricity. So ADC receive data in the form of electricity, and ADC then convert into binary form, and this binary form understood by computer, you can say understand by processor, and then it takes the next action. So here is the timing device, which basically adjusts the shutter. The timing device allows different shutter speed, so delayed action and so on, and it is coordinated with CCD when to press a shutter or not to press a shutter, kind of that. Got the idea? Yes, Naima, got the idea? Okay. So moving to next input device. Here you can basically go through keyboard, as you know that. Just go through quickly, then ask me if there is any question. So it comes in virtual form, basically touch screen form, but normally it is a physical. So have you gone through? Should I move to next page? Okay, here is further basically description is given, but one thing I want to tell you about, which we have discussed in chapter 1, American Standard Code for Information Interchange. Okay, this is called American Standard Code for Information Interchange. It has basically a series of character set. We can say character set. It is a basically character set like capital A to Z, small a to Z, or 0 to 9. Normally it has 256 character. Okay, possible 256 character is supported by ASCII. Capital A means the capital A always start from 65 onward. Small a start from 97. You can add in 32, and 0 start from 48. Okay. Now it says when we press a key, like if I press capital A, it is basically, it has a position value in binary form. It has a position of 65. Okay, and this 65 is binary converted into binary form, and that binary form is transferred to processor. It moves to processor, and then processor work accordingly. Okay, because processor can understand only binary form. Processor can understand only binary form. Okay, so each input device have ASCII chart. So ASCII chart basically is a character set which support all possible combination of character, which we can use for tapping purpose. Okay, so basically here this is repetitive strain injury. When you do typing continuously, you can be victim of this injury. So for production from this, they use ergonomic keyboard, can help to overcome this problem. Okay, just go through this one, then you can ask me question. Okay, these are some working is given. Like say there is a membrane or circuit board at the base of the key. So it is electric circuit, electronic circuit you can say, which is under the keyboard. In figure 3.25, it says the H key is pressed and this complete a circuit as shown. When you press the key, it connect with the circuit. So CPU in the computer can then determine which key has been pressed by converting from its position into binary form. The CPU refer to an index file to identify which character the key pressed. The index file means character set, that like ASCII chart. Each character on a keyboard has a corresponding ASCII value. See chapter 1. Got the idea? Okay. Okay. Now you can see microphone. Microphone also basically takes data in the form of analog. Whenever we speak, our data moves in this form, analog, which is not understood by computer. That is why microphone has also ADC. You can say ADC. So ADC convert into digital form like this one. This is digital form, 0 and 1. Okay, so that computer can understand what you have spoken. It says microphone are either built into the computer or an external device connected through the USB port or using Bluetooth connectivity. Show how a microphone can convert sound wave, basically it receive data in sound wave into an electrical current. So these are sound wave, whatever we are speaking. Okay, here is basically diaphragm is given. This is cone, and this is coil of wire wrapped around the cone. So permanent magnet is given. These are the parts of microphone, output from the microphone. Okay. So basically, whenever we speak, it receives from the diaphragm. Diaphragm basically vibrate, and this vibration is converted into electrical signals. So it says a microphone can convert sound wave into an electric current. The current produced is converted to a digital format so that a computer can process it or store it on, for example, a CD. Okay, got the idea? Okay, here you can see further steps are given. Like it says, When sound is created, it causes the air to vibrate. Or when a diaphragm in the microphone picks up the air vibration, so the diaphragm also begin to vibrate. Okay, the previous one you have seen that. A copper coil is wrapped around the cone, which is connected to the diaphragm. As the diaphragm vibrates, the cone moves in and out, causing the copper coil to move backward and forward. And due to this movement, this forward and backward motion causes the coil to cut through the magnetic field around the permanent magnet, so inducing an electric current. So using this activity, they can create electrical current. Okay, and the electrical current is then either amplified, means you can increase the volume, or sent to a recording device. The electric current is analog in nature. So it means when electric current is generated, then they are converted through ADC in the form of digital form. These are given. Like the electric current output from the microphone can also be sent to a computer, where a sound card converts the current into a digital signal, which can then be stored in the computer. The following diagram shows what happens when the word heard is picked up by a microphone and is converted into digital value. So here you can see when we speak heard, so basically it find out the corresponding character set. Like if it is A, it will be 65. So A, B, C, D, E, F, G, H. So you can add 10 words. So 65, 66, 67, 68, 69, 70, 71, 72. The H character will have a 72 binary number. It will be converted to digital form, binary form. They say, look at 3.27. The word heard in the form of sound wave has been picked up by a microphone. This is then converted using an analog to digital converter into digital value, which can then be stored in a computer or manipulated as required using appropriate software. The software can manipulate it. Yes, Nana, got it? Do you understand? Yes, Nama, have you read? Should I move to next device, optical mouse? Okay. Here, basically, optical mouse is given. So here it says an optical mouse is an example of pointing device. It is a basically pointing device. So it uses teeny camera. Okay. So to take 1500 images per second. When you move basically a mouse, so it has a camera which takes the picture, which produces image 1500 images per second. But unlike an older mechanical mouse, the optical mouse can work on virtually any surface. Okay. So before that, there was a wheel under the mouse. A red LED is used in the base of the mouse, and the red light is bounced off the surface. Here you can see red lights. It shows LED. Lens is given, surface is given. On the surface, we move the mouse. So there is a lens, basically, which capture the image. Mouse body given, CMOS, and lens. CMOS means complementary metal oxide semiconductor. Okay, here is description is given. So there is a lens. There are two lenses are given. It says a red LED is used in the base of the mouse, and the red light is bounced off the surface, and the reflection is picked up by a complementary metal oxide semiconductor. CMOS pick the basically its reflection. So the CMOS generate electrical pulses to represent the reflected red light, and these pulses are sent to a digital signal processor DSP. So the processor can now work out the coordinate of the mouse based on the changing image pattern. So as it is moved about on the surface. So when we move the mouse on the surface, continuously producing 15 image by the lens in a second, and these images converted into digital form, and that digital form can be understood by processor. The computer can then move the on-screen cursor to the coordinate sent by the mouse. Coordinate means X or Y position, X or Y position. So using this technique, a processor can understand where is right now mouse, where is pointing on the area. Basic computer processor has to determine where is position of the mouse using X or Y coordinate. Got the idea? One second. Okay. Just go through these points. Benefit of an optical mouse over a mechanical mouse. So you will take class tomorrow? Okay. Allah Hafiz.